Welcome to this explainer. Okay, we've got to dive right in today because we are unpacking an absolute breakthrough in how artificial intelligence systems actually collaborate with one another. We are finally moving past the days of just relying on one giant AI brain to do literally everything, and instead, we're looking at a brand new, highly efficient framework called Agora. It's an entirely new way for AI agents to bid on and trade reasoning tasks, almost like items in an economic marketplace. It is absolutely fascinating, so let's get started.
Here is our roadmap for today. First, we'll look at the AI overconfidence problem. Second, introducing the core idea behind Agora. Third, exactly how the auction works. Then, real-world scenarios, the results in plain English, and finally, the impact and our key takeaways.
All right, section 1, the AI overconfidence problem and the danger of trusting a single generalist model.
To really understand why Agora was created in the first place, think about this for a second. What actually happens when an AI is super confident but just completely wrong? It's kind of like hiring a general contractor who promises with 100% certainty that they can fix your complex plumbing issues. But when they actually get under the sink, they have no idea what they're doing. If you just blindly trust their confidence, well, your kitchen floods. And, this is exactly what is happening inside complex AI reasoning systems right now.
The technical term for this is hallucinated certainty. This is basically when AI agents claim extremely high confidence on an answer that's just flat out incorrect. And this is a huge deal because if we're trying to dynamically allocate tasks to different AI models and we don't have a reliable measure of their true success rate, we risk assigning critical logic steps to incompetent models just because they boast the loudest. When that happens, the entire chain of reasoning just completely collapses.
And that brings us to the massive bottleneck we're facing right now in the industry. The default approach for most people is static routing. Basically, we send an entire complex query to a single giant generalist model. But this totally ignores a crucial fact. Specialized expert models, models trained specifically for coding or specifically for math, they often vastly outperform those generalist giants on their specific subproblems.
Which leads us to Section 2. Introducing Agora, an economic approach to task allocation. So how did the researchers solve this bottleneck? Well, they took an economic approach. Let's look at a really simple comparison. In a standard AI setup, it's a lot like a traditional job market, where one single generalist handles the entire project from start to finish. But the Agora framework operates like a highly calibrated auction. It literally treats AI reasoning steps as tradable items in a marketplace. Different AI models can bid on the specific tasks they are best at. But here is the true genius of it. The system penalizes bids from AI models that have a history of overestimating their skills. It allocates the work based on proven, verified skills, not just empty boasts.
Okay, section 3, how the auction works. Let's map out this Agora methodology.
So, looking at the full pipeline here, starting from the left. First, in the task planning phase, an LLM planner takes a complex prompt and breaks it down into a graph of dependencies. Next, as we move into the middle, auction and allocation phase, different AI agents submit their bids based on their price, speed, and confidence. But, and this is absolutely crucial, notice the calibration logic step. This is the secret sauce. Calibrators fact-check the AI's raw confidence against its actual historical accuracy. Finally, the winning bids are selected, those subtasks are executed, and a result composer synthesizes it all into the final answer.
Now, if that architecture felt a little dense, don't worry. Here are the 4 clean, memorable steps you really need to take away from this. Step 1. Plan. A complex query goes in and decomposed task units come out. Step 2. Calibrate. Raw confidence goes in and verified, realistic competence scores come out. This is what fixes that hallucinated certainty. Step 3. Auction. The calibrated scores and costs go in and a winning allocation matrix comes out, maximizing competence while keeping costs down. And finally, Step 4. Execute. The chosen models solve their specific units and the final synthesized answer is generated. Moving on to Section 4. Real-world scenarios. Let's ground all this theory into some actual practice.
Theory is awesome, but we really need to see how this performs out in the wild. Scenario 1 involves a benchmark called Music.K, which is basically testing multi-hop question answering. The real problem here is answering complex questions that require you to connect multiple distinct pieces of information. Traditionally, a single model just struggles to hold all that logic together without hallucinating, but Agora, it decomposed the questions and routed the text-based logic steps to distinct models dynamically. By doing this, it achieved an exact match score of 43.0, totally outperforming the single model baselines and the standard cascading routers.
Scenario 2 dives into the Psycode benchmark, simulating some really intense scientific workflows. Now, traditionally, you would just send the entire complex coding workflow to a single coder AI and cross your fingers. But the Agora approach extracted specific task units and auctioned them off. On this test, Agora matched the absolute best single backend baselines, proving that even on highly complex scientific data, it can reliably parse out subproblems without losing the overall thread of the workflow.
And scenario 3 is where it gets really cool. Multimodal tasks using the SPQA benchmark. This involves mixing text retrieval from scientific papers with complex visual math. The traditional approach is to just escalate the whole prompt to a more expensive model if a cheap one fails. But Agora realized something brilliant. It noticed that the Grok model was excellent at text retrieval, while the QN model was exceptional at visual reasoning. So it just dynamically separated the tasks and routed them to the right expert.
Section 5. Results in plain English. Let's translate this benchmark data.
I promised no confusing tables, right? So let's focus on the intuitive takeaways here. Notice how those red curves dip way below the diagonal line of actual accuracy? That is the AI wildly overestimating its own ability. But then, look at the green curves. That's Agora's calibration working its magic. By applying that calibration logic, the expected calibration error drops drastically, shifting the green line right back up to reality. It successfully filters out all of that hallucinated certainty we talked about earlier.
And here is that functional complementarity in action for the multimodal scenario. On the left, we see Grok knocking it out of the park, scoring 85.4% on retrieval, totally beating Qwen. But Qwen scores 48.2% on reasoning, beating Grok. So what does Agora do? Look over to the right. During the retrieval phase, it allocates 81.1% of the work straight to Grok. But the moment the task shifts to hard logic in the reasoning phase, it strategically pivots, sending 32% of the work over to Qwen.
And because of that exact strategic swapping, Agora hits this number, 56.9%. I want to emphasize this heavily, because this represents Agora's strict accuracy on that multimodal reasoning task. The absolute best single model on its own could only achieve 48.2%. By auctioning those subtasks to the right specialists, Agora created a massive jump in accuracy that literally no single model could achieve independently.
But hey, what if you're a developer working on a super strict budget? Well, Agora has this single parameter called beta that represents cost sensitivity. As you increase that beta dial from left to right, the blue bars, which represent the usage of the cheaper Grok model, they go up, while the red line representing accuracy drops just a little bit. This single dial lets users easily control the trade-off between using cheap models to save a ton of money versus premium models for maximum accuracy, all without having to retrain any of the underlying models.
And that brings us to our final part, Section 6, Impact and Key Takeaways. Let's look at the strengths, limitations, and the future.
To be completely fair, we have to look at both sides of this framework. The strengths of Agora are super clear. It thrives from the candidate agents have complementary strengths, like, one being great at math and another at reading, and when tasks can be explicitly structured. However, its main limitation is that it really struggles with tightly coupled steps that cannot be cleanly broken down. If a problem is essentially just one giant, tangled knot of logic, Agora's planner has a really hard time auctioning it off piece by piece.
So why does this actually matter for the industry? Well, the practical impact is huge. Agora basically acts as a plug-and-play allocation layer. You don't need to do any expensive end-to-end retraining of your AI models to use it. It gives developers a direct dial to control cost versus quality. And perhaps most importantly, it structurally prevents systems from blindly trusting and over-allocating tasks to AI models that are confident but totally wrong.
Let's wrap this up with the crucial takeaways you should remember from today's explainer. The core problem is that AI hallucinated certainty ruins complex logic chains. The solution Agora provides is breaking those chains into units and running calibrated economic auctions based on true verified competence, and the results speak for themselves. This method consistently outperforms both giant single models and standard routing systems.
Which leaves us with this final kind of mind-bending thought. If AI models can now dynamically run calibrated economic auctions just to delegate their own internal reasoning steps, what exactly does the future macroeconomy of artificial intelligence look like? It is definitely a fascinating concept to ponder. Thanks so much for joining me on this explainer, and keep learning.